Hey everybody, this is Larry. This is me doing a new problem that I haven't done yet. I have to change some stuff to. Okay, there you go. I've been doing RNG, but I feel like maybe I'm just doing a little bit of a twist where I'm doing it from the newer problems first. So let's take a look. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. And today we have a hard problem 3141 maximum Hamming distances. So hopefully this doesn't take me that long because I want to eat some dinner. But given an array nums and an integer m, each element num sub I satisfying. Okay, I mean, yeah. I mean, just a number that's smaller than 2 to the m. Return an array answer. Right, I mean, that is just... The answer array should be of the same length of nums, where each element answer sub I represent the maximum Hamming distance between num sub I and any other element num sub j in the array. Okay, the Hamming distance between any two binary integers is defined in number position they differ. Okay, let's think about what that means. There are a lot of hints, but obviously we'll try not to, at least definitely not click on them like 2 seconds into the problem. But okay, so now we have, and they're all the same. I mean, they're effectively the same length, I suppose, because you just have leading zeros, right? And then you're trying to find the maximum. What does the maximum mean? Right, the maximum difference is also the same. Yeah, I mean, I think so. The maximum difference is also the same, the minimum sameness, right? So basically, for example, this one has 2 characters the same as this. So then now we have to do it for each character. Oh, I did not look at this enough. Oh no, m is 0 to 17. Okay, no, I was wrong. No, because I saw m is 0 to 17, I thought it was like a 2 to the 17 thing, but no, that's just the number of bits. And we can actually have a lot of numbers in the input. What is 2 to the 17? Wow. Okay, only 130,000, so I think that's about, but clearly n squared is not going to cut it. I mean, I kind of expected that, but I just wanted to make sure. Okay. I mean, I think the first thing I want to do is sorting, but it doesn't. I don't know that it gives me anything, so maybe I'll put that. I'll just write it out. Why not? But so something that is least similar. I mean, there are a couple of ways to think about this, right? So, and I'm gonna just write notes on the screen so you kind of see my thought a little bit. I don't know the answer yet, but yeah, basically, we're trying to find max distance, Hamming distance. I'll just call it h distance maybe, which is also similar to min same characters, right? But keeping in mind that if you invert everything, you can it also, like if you invert the zeros and ones, then you're actually trying to find max same characters as well. Now, so basically, we have every possible thing, right, that we want to do. We either get the min or max. So, and the idea here, I don't have any ideas yet or specific ideas, but the plan of attack is just that these are the ideas that we can explore and see which one of these is the easiest to do, right? Yeah. And I would also say that I think I didn't do the intro right. Today is May 23rd for today. I think it'll be I might stick with this format a little bit because I think the more recent problems that they put up are a little bit more difficult, and because they're a little bit more difficult, I get, or like they're more calibrated difficulty wise to the contest. And of course, during the contest, I do have explanation videos and stuff like this, and afterwards, but I don't explain during the contest as much because I'm trying to like get it out as soon as possible, right? So hopefully this will give me a little bit more insight and to be articulate about it, even though I'll be on average a little bit slower than I would be during a contest because I'm explaining things. In any case, okay. And you have 17. Don't know what that means. I mean, I think 17 is just to bound this by 100,000-ish. But, Or like my thing is that these things are kind of nice, but or max opposite characters, but same of something like this. I think for me right now, I'm just trying to think about the visualization, because basically now. I mean, so these are kind of things, and the first things that I explore was just a very generic work for any type of things not relating to binary numbers. So like if you put in a word, like a string algorithms, and I've been trying to think about those in my head. I don't see anything obvious, but now I'm trying to think, okay, now if you think about Hamming distance, because for Hamming distance, you can actually, or for a binary number, and this idea of Hamming distance, you can think about a binary number as an n-dimension, or in this case m. You can think about it as an n-dimension hypercube, and the Hamming distance is and each number uniquely determines a point on that n-dimension hypercube, and you're trying to figure out, well, in this case, the longest path. Or maybe, like I said, the max of the shortest path. Yeah, max of the shortest path to that, right? I do wonder if there's like some property that we can exploit a little bit. Because basically so one idea that I'm having right now is just to run shortest path on all of them. Of course, if you do it naively, it's going to be n squared, right? Because for each n vertices, we do an O of n, whatever, shortest path, right? And of course, that's going to be n squared, which is way too slow. And of course, if you have n squared, you could just do a loop anyway. But the thing is that we're not trying to find an all pairs shortest path, right? What we're trying to do is find one node that is the closest to all of them. And in that, I don't know that and I'm trying to figure out like what is the proof on what the upper bound for that would be. I'm trying to think of some ideas on that, because basically the idea is that, okay, well, look, if one node is going to be 17 distance away, but you have to, and 17 distance is literally going through all the 2 to the 17 nodes, then that's going to be really bad, obviously, right? But, however, there is some sort of, not pigeonhole, but there's some sort of forcing function, right? Because now, okay, let's say you have 2 points that's 17 distances away, so that you have to revisit all the intermediate nodes, which is all 2 to the 17. Then sure, that's going to be n squared. But if you have 2 nodes, that's true. But if you have 3 nodes, there's, like, you can almost think of it like, you cannot construct a circle in a thing, right? Where, like, there's almost a sort of a triangle inequality kind of thing, right? That I'm trying to play around with the idea of that. Okay, if there's one node, or like, we have 3 sides of a triangle, then yeah, okay. Then like, what is the farthest distance from that, right? From 3 things, because there's no. I want to say that, and maybe I'm wrong on this one, but I don't think I am exactly. I mean, I'm doing hand waving, but I'm just trying to figure out the upper bound, right? But you cannot have 3 nodes that are 17 distance away from each other, right? in the worst case, because there's no like, in a planar graph there's a triangle inequality, like I said, but even in this graph, like the literal 17 distance away, and I say 17 because that's the upper bound of m. So basically, that means all the digits are the same, right? Because it means that all the digits are the same. Oh, I guess. Well, I guess in the way that I defined it, I'm wrong. Now that I think about it, because then, like if you implement it very naively, in the way that I said, then actually, all numbers could be 16 and 17. No, wait. Or well, they're 16 or 17 distance away on the max of the opposite characters, which gives us this like early termination thing. But then also means that it also means that you can have 17 on all of them because they're just all the same characters, and you can have 16 to all of them because they're all words divided by one, or with one difference. And then now my idea is, okay, can we do a what's it called? I forget what the naming is, but basically a distance search from both ends. Basically, you have min the same characters and max the opposite characters. So if you do a search on both ends, then you should be able to kind of converge more quicker. Because then now the worst case is going to be if the path is 17, so like 9 away, right? And 9 away is still not great. Because that means that each node takes 1,000 operation, and we have 100,000 nodes, right? So that's still a little bit too slow, I think, because that's like 10 million operations and a very sketchy 10 million, because I think the cost is not, like I think there's like another O of n cost or something maybe. So that is a fun idea to play around with. And of course, you could divide the work by 2 and have bounds or something like this. But that's, I mean, okay. So that's like one idea that we're playing with. I don't know. I think the thing with this problem is that it's so simple in the statement that that I'm trying to think whether like what else could there be? Like I thought about the string stuff. But I'm just trying to think about like try type algos, but I don't think I see one there, or even suffix trees and stuff like this. Like I said, so I'm back to think about string algorithms and not the shortest path on kind of thing. And I think if I don't have many ideas, it is something that I could play around with. But to the 9, I guess maybe that's okay. No, I don't see a easy way to optimize that out, because you can just have, what's it? We can have 100,000 numbers, so about like half of those would be. It's like in the worst, like in the worst case, it would just be like a bunch of these, and then the other half would be just something like this, and then that means that it would take the full 2 to the n over 2 work. So it's gonna be pretty slow. I wonder if there is a way for us to play around with is there I'm trying to also think whether there's like a big small universe thing that we can think about. And we can sort. I mean, we could sort, but we have to be a little bit careful because we have to return it in the terms of input. Drop my mouse pad or my wrist mouse pad thing. This is interesting. Oh, so I was wrong in that it's not symmetric, huh? It's not even like a diameter thing, is it? I'm trying to think whether there's like any divide and conquer-y things, but it kind of is similar to how you would do it with a try, so I don't know. in like different implementation, but the same idea maybe, which I don't know that that's. Can you merge one at a time? Well, if you merge one bit at a time, how would that work? You still have to, the merge is still n squared. I don't know that there's an easy way to get around it. Is there like a square root solution? N times square root of n. I guess n times square root of n is still. Is there like a small universe? Okay. Maybe I just don't know this one. I don't know. It's interesting. I'm trying to think what it is. I could be really sad because I think 10 million is actually maybe close to reasonable if we use C++ and not Python, and that's why I'm like, if that is the reason, I'll be very sad, to be honest. I'm just thinking about it. Mm. Can we do all the? Am I just being dumb? Can I do all the BFS at the same time? Does that help? Okay, like what is the worst case here? Okay, I mean, let's say we get to a node. What does that mean? Oh, if we get to a scene node, can I do it together? And then kind of just merge them in a weird way? Oh, wait, you can do it in reverse and then visit all the nodes from the reverse nodes. Oh, can you? Then now, and then it just flows the graph anyway. And it'll be the shortest path as we said. And we're taking the max of just okay. Let me. I see. Yeah. Why? Wow. I'm like really dumb today, I guess. Okay, I see. No, then now if you think about it, I see. Okay, I'm just gonna I mean, I think I get it, but I'm gonna draw a little bit things, so that I can explain it a little bit better, and maybe convince myself that is right. That's part of it as well, just to make sure. Okay, so I mean, I think this is, not that much on. Like we can generalize this a little bit, just because I don't want to draw everything, but basically you have some nodes. And the idea that I was trying to think is that if we can create a shortest path for each. So the reason why I had the long solution that I couldn't figure out to work was that, okay, if you invert the bits, then now instead of getting the max distance, you're turning the max distance to shortest distance, right? Because because we're converting it from min of the same characters to max same of the opposite characters. And now we're getting the shortest path. And not even the shortest path, we're getting the first small path from this node, right? And the thing that I couldn't optimize out for a while is that for each node, we're trying to find the first smallest node from that. but that is, and then I was trying to think, okay, we have a multi-source BFS. How would we kind of but no, then you're basically now trying to get from the endpoints going backwards. Because now that if you're trying to get from the endpoints going backwards, then you just throw the graph, and then you have all the graph from the endpoints to the beginning. Why is that? I mean, that's fine. Yeah. Because I think wow. I mean, I think the hard part about this is that this graph of multi-source is not symmetric, right? Meaning that it matters whether you do the multi-source shortest path from the destination or the starting point. The starting point. I'm blanking out in words. And because of that, because I was trying to think how to do multi-source from the starting point, and from the starting point doesn't really make sense. And this is kind of very basic BFS multi-source stuff, but maybe I'm just very rusty. Because the thing is that you can reach nodes that you've seen, but you cannot early terminate. So it's kind of weird, right? Because your multi-source is a little bit different. But if you do it in reverse, then now you just keep going until you see all the nodes. Okay. Wow, that's a hard problem. I don't think I did the graph because I don't think I could draw it very well. That's why I didn't continue the graph. Okay, so then now I am not very good at this stuff. Okay, so then we start at the reverse of this, and the reverse of this is just let's say max is equal to 1 shift m minus 1, right? So then now this and that is not what people ask me why I do left shift sometimes, and for this one it makes sense because it is doing we care about the bits more than we care about the 2 to the m per se, so that's why I do it this way. Okay, so then now s is equal to start, best of s is equal to 0, q dot yeah, it's a buffer search, right? Yeah, okay. And now we just throw the entire graph and that's it, right? C for current. Okay, and then now for x and nums, we can do it again. Oh, I have an answer. Best, I think it's actually the max, which is the number of bits. Because we want the opposite of the. I'm not really good. This took way too long to figure out, to be honest. I mean, how long did it take? Let me take a look. Wow, half an hour. This is one of those things where once I notice the answer, I feel like I should have gotten a little bit better. I mean, obviously, during a contest, I would have been slightly faster in the sense that, well, I would not have explained it before I solved it, but I like this problem. It's a very good problem. I think it's a very interesting problem. It's a good twist on a like everything you need on this. The reason why I like it is because everything you need for this problem is pretty basic, in the sense that it is just multi-source breadth first search. Of course, there's some maths around Hamming distance. This idea of n-dimensional hypercube, which you don't technically need, but it kind of gives you the visualization if you could visualize things in n dimensions, and kind of playing around with the distances, and it did kind of, and yeah, I don't know why it took me so long, because I got the ideas pretty quickly, or the components of the ideas, which is I guess this part. But what I was thinking of is starting from here, doing a breadth first search on each of these numbers, with each of these numbers. And I don't know why it took me so long to kind of play around with the multi-source idea. And once I saw the multi-source idea, I was trying to think why I could not do it quite right. But the reason why I couldn't do it quite right was that, like I said, it's asymmetric in whether you're starting from the starting point, or the input x, or the opposite of x, which is this thing, right? And yeah, because basically now you're just saying, because we reduce this to a shortest path problem, to like I said that a few times, but the variation that you want to consider is that given this point, you have multiple exits, you have to find the closest exit, right? That's like another way of putting it. And but then now you have multiple people all looking for the closest exit from them. And that's a very basic transformation of just doing a multi-source array. Not to say that that's an easy explanation, but it's something that I believe I should have a pretty good grasp on. But I think I just didn't phrase it quite that way in my mind, because I think I got mixed up in the queries, and I didn't think about doing them together in a multi-source kind of way. That took a while. Because once I started thinking about that way, then there are really only two possibilities, I suppose, but I just didn't really think about it. And I think the other thing is that, and I talk about this on my daily video a little bit, which is that problem recognition is a key part of this, right? And what I mean by that is just that if you know the problem category, like if someone put this in the BFS, like if we have 4 BFS or 4 shortest path problems right before this, maybe multi-source, then I'll be like, oh, okay, maybe like there's some thing ingrained in my head. But because I don't know what to expect from here, which is what I want to practice on, because that's the part that it's realistic, right? You're not given this stuff. I was able to, or like it challenged me in a way that I didn't expect, I think. What are the hints? Maybe I could have gotten it complimented. That's not really a hint, that's like an instruction. I think a hint for this would be like, can you convert it from a longest path to a shortest path problem, right? And then like maybe this is like the third hint would be nice. This being a hint number 1 is a little bit heavy lifting there. Yeah, I mean I even have this here, so yeah, I mean this is the hypercube stuff I was talking about. What I source from the elements of nums. Can I do that straight from the I don't think. Well, maybe it depends on how they phrase it. Well, I mean, I guess if you already complimented, then maybe, but it's a little bit weird phrasing depending on how you read it. But I mean, that's fine. That's basically what we did. Let's go over the complexity really quick, right? It's just going to be, roughly speaking, 2 to the m, which is, or O of n plus 2 to the m, I suppose. Depending on how you want to say 2 to the m, because technically this is not the input size, right? The input size is actually like let's say b is the number of bits to represent the number m, right? Then this is actually O of n times, or n plus b, or 2 to the, oh wait, I guess they give you m and 2 to the thing, so maybe this is right, I don't know. But yeah, the reason is because this breadth first search, at least the way that we wrote it, maybe you could do an early termination. This is going to go over the entire range of 2 to the m right here, so it's going to be, and this is also space, of course. Well, I don't know why I just wrote that way. But because that's also the output space, right, for the O of n part, 2 to the m for the other parts. But for the breadth first search for a graph of 2 to the m number of things. It's a very cute problem. I'm 40 minutes in. It seems like I think I feel like I was definitely slower than I would like. So it's good practice though, especially for very fundamental problems. I feel a little bit bad about it, but oh well, can be good every day. So especially if I'm not prepared for it. Anyway, that's all I have today. I also ran 10 miles today, so I'm just going to blame it on that. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.